Air pollutants are gases or aerosols in our atmosphere that have harmful effects on human health, on plants, or on materials. Impacts of air pollution on human health can be chronic, acute, or carcinogenic. Chronic impacts refer to a gradual deterioration of a variety of physiological functions over periods of years, which can happen, for example, with lead poisoning. Acute impacts refer to life-threatening reactions within a period of hours or days, and carcinogenic effects are cancer-causing effects, for example, lung cancer. We differentiate primary pollutants, which are directly emitted pollutants, from secondary pollutants, which are pollutants that result from chemical transformations of primary pollutants. Sources of air pollutants can be natural, such as volcanoes or fires. They can also be created by humans through a variety of ways. Three major human sources of air pollutants are power plants, traffic, and industry. If we look at it only by volume, then our biggest problem is carbon monoxide, followed by nitrogen oxides, volatile organics, sulfur oxides, and particulates. In this context, the transportation sector is responsible for the highest amount of pollutants. Carbon monoxide is an odorless, colorless, and tasteless gas. It is dangerous because it displaces oxygen in the bloodstream, which leads to headaches, vision and judgment losses, and, if the concentration is too high, to death. We get various forms of nitrogen oxides. Nitric oxide, NO, is non-toxic, colorless, and odorless, but it can oxidize to nitrogen oxide, NO2. Nitrogen oxide is a yellow to reddish-brown gas with a pungent odor. It leads to an inflammation of the respiratory system. It can destroy lung tissue and damage plants. The main human sources of nitrogen oxides are related to high temperature and high pressure combustion. Sulfur oxides are colorless and have an irritating smell. They affect humans by impairing breathing, and they affect nature particularly because they lead to acid deposition in form of sulfuric acid. The main culprits for sulfur oxide emissions are coal-fired power stations. Given the high concentration of coal-fired power stations in the eastern part of the United States, it is no surprise that we find the highest levels of acid rain and acidification of lakes and rivers in the eastern part of the United States. High concentration of particulates in the air have extremely negative health effects on our respiratory system. All three major sources of human air pollutants contribute to high levels of particulates. The negative effect of volatile organic compounds or hydrocarbons in our air is related to the fact that these are the prime agents of photochemical smog. Photochemical smog, also called Los Angeles type smog, results from various ingredients such as nitrogen oxides, VOCs, carbon monoxide that react in the presence of UV radiation. The problem is that this reaction produces ozone, which is a highly reactive, unstable gas that damages the respiratory system and causes bronchitis, pneumonia, and is highly dangerous to asthmatics. Another form of smog is the so-called industrial or London type smog that is based mainly on sulfur oxides, particulates from burning coal that mix in fog or humid air and produce this gray industrial smog. The worst event of industrial smog happened in London in 1952. It resulted in thousands of deaths. Natural sources typically do not create high concentrations of air pollutants. Pollution problems occur when we get high emissions over small areas. Atmospheric processes influence the pollution concentrations as they are responsible for the horizontal and vertical dispersion of the air pollutants. The wind direction certainly plays a role, but also wind speeds, as strong winds disperse pollutants through rapid transportation from the high concentration source. The vertical dispersion of the air pollutants depends very strongly on atmospheric stability. An unstable atmosphere will promote the mixing and prevent high concentrations near the ground. However, a stable atmosphere, and in particular an inversion layer, will block the mixing and pollutants are trapped beneath the inversion layer. Following the Clean Air Act of the year 1970 and the establishment of national ambient air quality standards, we have seen an improvement of air quality regarding most parameters. However, air quality standards have not been met in a large number of places, and positive effects have partly been offset by an increase of vehicles on the road. It is clear that additional controls will be necessary to ensure clean air.